Okay, so this one is the learning outcomes with the index, then I compare the performance whether you have an index or you didn't have an index. Then the last part here is explain the role of inverted index. Okay, so this one is a new topic, inverted index in locating a document in the collection. So we may have some others indexing structure or method, but it's too much for us. Okay, so if we want to go to that deep, maybe if you want to continue your master or PhD, then maybe you can continue to this part. We have for this indexing, actually you have a lot of different methods. So previously some of these master class students, they actually try to do this. So of course, the topic is too boring, and the result come out is somehow hardly can be compared. Okay, so these are the different kind of this indexing structure. Okay, so we go through the starting. Okay, index are special lookup data structure. So previously, I think you should already learn a data structure, let's say Java, OOP, or this C. When you are learning this project in C, maybe you can do some kind of this data structure. But for index, the data structure seems like quite obvious. If you learn a hash table before, in a Java, you should learn a Java data structure, you should learn a hash table before. Okay, so this lookup data structure is a link to the actual location. So this will help the search engine to speed up the data retrieval. So when they try to look for something, you actually have a very systematic way or a location method, try to locate very fast to locate the number or the key, then go direct to the actual location. Okay, so this one is the index definition. Of course, the main part is lookup, and the second one is the speed will be very fast. Okay, so this is very similar to this book index at the back of the book. So normally, during my time, the internet searching is still not that good. We may still need to use some kind of this thing called yellow pages. Yellow pages at the time when Google is still not very popular yet. We have this MSN and this Yahoo. At the time, we have this thing called yellow pages. So you need to go to the directory, search the topic that you want, browse it one by one, rather than key in something in the search engine and get the result directly. Okay, so compared to that directory or yellow pages, if we didn't have internet, then actually we have to go to library and look for this book index. Let's say you want to search for one topic, let's say indexing structure, then we'll go to library and go to IT or computing book, then we just click in the book index. See whether they have this topic called indexing structure. Okay, so this one is something that we did before. I did before, but not you. Okay, so this one is one example. Another example is this book catalog in the library. I think currently none of us will go to library anymore, right? Don't know whether K-Ta library in the Kampar campus still have anyone go to borrow book or not. Okay, so the book catalog is actually a booklet, and maybe they already convert it into digital computerized. So what you need to do is use a search from the internet or from their computer, and hopefully you can get the result immediately. Okay, so previously I think from the last few semester, after you learn something in a K-Ta, normally a lecturer will always tell you, okay, your subject code is BACS 3183. Okay, so what you need to do is that you go to our K-Ta College University website, and just go direct to a library, and just search for the subject that you would like to search. So this one, let's say BACS 3183. Okay, so it will be fast, right? It will be very fast that you can get a lot of related subject or related to this keyword BACS 3183. So this one is all the past year exam paper. I think after you finish your assignment, you should start looking at it and start trying to do and look for answer as well. Okay, it may be a little bit changed for the past few semester. Is actually we actually have a little online assessment, but aside from this sem, we'll go back to seek for the actual exam. Okay, so book catalog or any thing we can just search from the K-Ta library. Okay, so not only a search for past exam paper, but search for textbook as well. Whether they have any of these e-book or physical book in the library, because a lot of us is not coming back to campus until the end of the semester when you sit for the exam. So no one will go to a library to search for this. Okay, it's okay. So the part here is when you want to search something from the large number of blocks holding a record. So this one is a lot of record. We take it as example of the book in the library. So if you want to go and look for it one by one, I think the whole week you stand there and look for it, you still are not able to finish searching what you want. So what is the solution is you go to the library computer and just type something, then the computer will help you to look for the keyword. Okay, so in order to much more faster getting your result, it will have this thing called index structure. Of course, the computer system or the library system will automatically do it for us. We do not need to click or pick this index structure. Okay, so of course, for us, 1 to 2 second delay of this searching, it won't be any problem, or we not even discover this problem. But if millions times of searching and each time it costs 1 to 2 second delay, then combine of this millions times or billions times together will be a big problem. So for the objective, you will need to check the performance before and after apply this index. So this is the main objective of this. So try to do it and see how many second or millisecond is reduced after you use this index. So the way of index for our SQL to create an index in the Oracle using this method, create a unit of index name, okay, create index, the index name, and for which table. So for which table at the same time for which column. So whether it's ascending or descending, previously when you do or when you create this table, you actually already have the idea whether it's ascending or descending. Okay, so let's say for some of the book record, a lot of time because of the year of publish, normally the last one to join into the library will be much more popular compared to the old version or the old publish. So it should be descending. Okay, so it will be at the top. So normally when we look at it, it will be much more faster to display the result. Same thing for the past year exam paper. Maybe when you want to look for it, you want to get the newest one rather than 10 years ago past year exam paper. Okay, so this one is descending or ascending based on the table structure that we create before. We think it should be based on the year, then it's descending when it is published. Okay, so this is the example. Create index, the name of the index, and then on the customer, whether you want to put ascending or descending, it is okay. Okay, so you can see the square bracket here telling you that this one is optional. If the previous one customer, when you customer table, when you didn't specify whether it's ascending or descending, normally it's ascending or the alphabetical. Okay, so this one is to create the index. The last part here is after you create the index, you also need to learn how to drop this index. Okay, so when you do the testing of creating a little index, then search again. You know how long it takes to get the result, then maybe you can drop it, then try again. Okay, so try a few times, then you will know how fast is it with or without this index. Of course, for our data, for our database, the record won't be too much. Okay, so previously the order detail, that one is only a 2,996 record. For our computers memory, this one is like a jumbo. Okay, so it's not that much. But if we want to search one by one, and the time is previous computer is using a hard disk, not SSD, hard disk, and we force the computer to read the record one by one, then it actually will consume a lot of time. Okay, so of course, that's how we mentioned for 1 second, for one is okay, but let's say for 100 or 1,000 or even let's say million or billions of records, it actually will let you know how slow is it compared to before using this indexing. Okay, then continue. We more explanation about this index structure, how it actually works. So an index contains a collection of entries. So this one is the entry. Normally they will have a one record table. So let's say if the user search this keyword, then they will put it inside this table. So next time when we do the searching again, it will be much more faster. So a collection of this entry. For efficient retrieval of all entries with a given search key or value of k. So you can see the search key k here is actually a path to this collection of entry. And this is a collection of entry, a data entry. We'll go through and check a specific location. After you get it, then it will just directly pointing to the place. Okay, so this one it will just point to the record, let's say number 3 here. So directly, the searching of this part will be compared to searching the whole table will be much more faster. Okay, so to locate data record with the search key value, so step by step, search the index using k to find the desired index entry k. So use this k, search inside data entry here, get the place or record of k, then directly pointing to the table. So the index entry k contains information to locate to the location. Inside here should have one or location, one or more. So that the keys we have always have one or more. Maybe k is not only in a data record, but more than that, then it is one or more data record with the search key value k. Okay, so this one is more specified. This one just give you a basic idea. So same thing, we get the keyword k, and compared to the previous picture here, we have before we have this thing called location mechanism. So if you take this data structure before, you should learn binary search, insertion, sorting, searching, a lot of different searching methods. So search one by one, okay, search one by one, or search from the middle, then continue break the whole table in, break the whole array into half, then get the result will be much more faster. But of course, the algorithm that we use is the one here, location mechanism. So how fast you can actually locate the keyword k, this is the performance of this index structure. Okay, so just I already mentioned this. For this index structure, the location mechanism or anything about indexing, it can become a big topic during your master or PhD or research. So until now, there is no such thing called it is 100% that this method is better than all others. So that's why this part is just telling you, okay, this one is the location mechanism. We didn't actually say, okay, binary search will be the faster one, and then we use binary search. Okay, so it may have any other searching methods that are trying to look for this keyword k in the index entry. Then after we get it, then it will just point to the table. So once the index entry is found, the row can be directly accessed. So this will be much more faster. Okay, so continue to the next part here. You mentioned that it mentioned that we have this index method, and we want to look for this key SL, okay, to be Florida, a state in the United States. So based on the query, it mentioned that say the customer state equal to SL. You want to list out all the customer name state from the customer table. So this is the customer table, and we have 14,786 rows here. Okay, so you already give you the number. So it also means that if we want to search this table one by one until 14,786, it means that we need to run this amount of time. Okay, so a lot of this searching query or searching algorithm, he didn't mention if you already get the number or if you already get the record, whether you need to stop or not. A lot of times you need to search from the top until end. Then you put that, oh, this is the record that I have, and I pass it to you as a result. So for the example here, it also means that, so this one is the table, and if you want to search from the top until the end, it means that you need to search this number of times. And the IO of this asset, let's say this table is stored inside a disk or hard disk, should be say hard disk. So if we already store this in hard disk, so the database need to go and read this table in the hard disk one by one. It actually, of course, a lot of this input and output request. So every of this record, if you read request for read, get the result. Okay, this is not what I want. Continue request for the second one until the end. Okay, so the example here telling us that if we're using this index method, it requires a total of 10 IO access. Okay, only a 10 IO access, 5 access to the index and access to the data. So we have a 5 record here. So we access this index 5 times, then it points to the table 5 times, we get the result. So this one is 10 IO access rather than 14,786 record IO this number of times. Okay, so the saving will be 14786 minus 10. So this one will save approximately this number of IO requests. So this tells us how what is the difference between using an index and non-index. Okay, so during our exam, maybe you need to give an example why you want to use an index and why not. Okay, so the next one here telling us if an index is so important, you see the speed. It seems like if one access is 1 second, if one access is sorry. Okay, so if one access is 1 second, then to save this amount of a second, then it will be around 4 hours. Okay, so of course the access of one, it won't cost you 1 second. This is the example. So the time saved is around 4 hours. So you can see the difference between index and without index. So the problem here is if an index is so important, why not we just index everything? So it will be much more faster, isn't it? Okay, so the question here, it may be your exam question as well. So since the index is so important, why not we apply index for all the table and all the attributes as well? Why not? The reason is not practical. Okay, so the taxes here, this one is the overhead. If we apply this index to our table, it also means that this DBMS is actually need to do every time when you insert one record to the table, delete one record from the table, update the table. It actually need to do some kind of thing behind it back in the background. So this is what we call index maintenance processing. So every time when you do this insert, update, or delete, it actually need to do the maintenance. So if it has many attributes and many rows, then the index maintenance process will take a lot of time. Okay, so this one is the reason why we not recommend to apply index to all the table and all the attributes. So this one is the reason. Okay, so we finish this part and continue to the next one is explain or give you the basic knowledge, understanding of this index structure. Okay, previously I already mentioned this indexing structure is actually a big topic, and it can be even a continuous study until your master or PhD. It is quite boring. We actually need to face a lot of this data and the result, try to analyze the result, why this one is faster, this one is slower. Based on the different sample of a comparison, it actually take a lot of time. Okay, so previously in Australia, one of the universities actually have one group of different master or PhD students join together and try to analyze using different kind of structure, whether it will be much more faster or it didn't have any result come out. So of course, based on the different data size, the result is always different. Okay, so this one is some common structure. So we have this hash index. We also have this B3 and this big X. Of course, based on a different based on the different scenario or circumstances of your table, it actually apply. It actually can apply to different. Different indexing methods. Okay, so you can see we have this customer table here, and in the middle of this is the last name. So we have this B3 index on customer last name. So this is the customer last name, and the middle here we have this Lee, Mr. Lee. So Mr. Lee is the root of this B3 index, and before Mr. Lee, we have this D print. So D print is here. Okay, so you can see it's another middle of the list, and box or rock is also the middle of the list. So if we continue look down to this part, so after D print, we have Adam. You know what? The capture of this picture is not so good, but they just leave it. So you can see the colony with until the last one here is Lee. So this one is the name, okay, the name and some of the linking to the customer ID. So if we look at this kind of a structure, it is a balanced tree. Okay, so if this part have a one record, then another part is will have another record. Okay, so how many record is inserted here? How many record is inserted in others? Okay, others. It tries to balance. Of course, here have a four, here have three. It's still not that balanced, but it try. Okay, it try to balance all the three. If we insert left hand one, then we will try to insert right hand one record. So try to balance the three. Okay, so you can see from this B3 index here, it also tells us the record is actually based on the customer last name. If we want to find the record, so let's say call Adam, we will find this Mr. Lee. Okay, Adam is actually less than. I use the key, the comparison word. It's less than. A is less than L. So I know that when I want to look for Adam, it should go to this part. Same thing for D, print. If I want to look for Adam, I should go to this part. Okay, so then when I go to this here, I actually get the Adam. So this is the record. So I know that the Adam customer number is 12. Okay, so I can directly access to this customer ID 12. Okay, so this one is how it works for B3 index. Then I'll continue do a comparison to the next one. We have this a bitmap. So you can see from our example here. This a bitmap. We have this a table, and this table has this region code, NW, SE, SW, or any other. So the region code here, if we want to browse or we want to select those customer is from, let's say, NW. So how are we going to list it out? We still need to go and look for it one by one, correct? Okay, so if we tell this index, this is the method of we search through all the table, and those attributes that is the NW, and we will just list it down. So this one is when we didn't have an index, we try to do it this way. Okay, if we have an index, this is the way that we try to do it. Because based on the different region, normally we only have 4. So NE, NW, SE, SW. So we only have 4 regions. There are regions to break it down. So if we have the bit set to 1 in a specific region code, then we know that this customer is actually from that region code. So you can see from here, only a 0 and 1. Again, the capture of this picture is not good. I think this one is 0, but actually it's 0. Okay, so you can see from the first row here, only an NW is 1. Second row here is SE is 1. The next one here is SW is equal to 1. So if we want to find any of the customer is from the NW, we will just say based on this index, all the NW which is equal to 1, then it will just tell you the location. Then it will point to the customer ID. Okay, so this one is based on a different case. Okay, based on a different case, we may need to use different methods, different structure of this indexing. Okay, so we already go through a B3 and a little bitmap index. Continue with the next one is this hash index. This is the more commonly used. Okay, even the programming, let's say Java or C. I think for the data structure part, at the end of the semester, normally it's until the end of the semester, you will go through this hash index and let you play around. If you want to find something, you need to create a data structure of this and try to insert some record. So I just show you some samples. Okay. We try to use this CP3 through Java class as an example. So we have this hash map here, and it actually allows you to, or you must not allow, you must insert 2 strings in order to build this hash. And the first one here is actually trying to put the country. Then on the second one here is actually the city. Okay, so capital city. So for England is London, for Germany is Berlin, for Malaysia is KL. Okay, so this one is the capital city. So when we try to run it, at the end of this part, we say that this one is try to show the capital city of England. So we have one data structure, try to get the result here. So the result is London. So this is the way that we build hash, and this is the way that we try to access. This is the key, and this is the location that we want to look for. Okay, so this one is the picture of using programming, how you're going to use the hash in order to get the result. Okay, so this one is something that extra. So we know, this hash, the way how we're going to get the location based on the input or the searching key that we provide. Okay, so we have we go to the example of this hash index. We need to get we need to know the ID, or you should provide the ID. Actually, you should provide the ID, and based on the ID, you will go through the hashing function. So this time we already show you the hashing function. You actually get your ID, then try to look for it inside the hash table. So once they get from the hash table, they actually can point you directly to the location. So I think that this picture is quite good already. So the hashing function is the one that we just mentioned. It can use any programming language, or even for most of the search engines, actually they build their own language, whether they use C++ or they use Java or any other language that we don't know, they may develop their own. Okay, so this one is the way that the way that they write hashing function and how we're going to get this individual record. Okay, so until this part, okay. Okay, if no problem, then continue. So this time we already mentioned introduction to the index. We also tell you the performance of using this index before and after we try to do the comparison. Okay, then the next part, we also have the basic introduction of AV kinds, a few kinds of this index structure. So up to this part, we'll continue mention the full text database system, and this is index the web. So we have this full text database system. When before we have a computer, everything, if we go to library, we need to search the keyword book by book. So we go to look for a book, then we click to the index part, searching for the keyword. Okay, so this one is the original method. So after we have a computer and we have this basic, or when our programming or the software become more advanced, we actually are trying to store and access all these documents, book, in electronic way. Okay, so if you buy a book, then eventually you can scan everything, then sit inside your computer. So next time you do not need to bring your book alone. You can just open a tab and just look for it. Actually, this Google, they actually are selling a book and in a PDF method. So if you go to this Google Play, actually you can buy any book that is published using this Google Pay store. You can get a copy. Okay, so a lot of these authors actually they try. They already know for the next 10 years, no more or no people will buy books anymore. So they will continue digitalize. So if you buy something from the Google Play store, only your tab or only your account can do it. So if you log in or buy this book using your account collect your email, so for the next 10 years or 20 years, you can continue reading this textbook. You don't need to worry if the textbook will broken or whatever. Okay, so a lot of this book is actually digitalized, put into computer. So for storing and accessing this document collection, such as newspaper, archive, research paper, and article, etc. So everything tries to put into digitalized. Okay, so the problem is we already put everything into digital, but how are we going to index it? When we want to look for it, how are we going to get it? So this one is a big problem as well. So I use this example. I think 2 to 3 years ago, I read one newspaper. It mentioned that in KL we have some Chinese a volunteer. They try to capture everything in the newspaper and try to digitalize. So those story or those articles is actually regarding Chinese from China. Then what is the history from maybe 50 years or 100 years ago until now? They try to put all these things digitalized. They scan the newspaper or any article that they can get and put into database. So the problem here is how are we going to index all those texts, all those articles? So this one is the method. Okay, so if they already put everything into their computer and put it online, actually Google will have a very good method to search it, and eventually everyone can see it. So not only for Malaysian, but for all others, Chinese or all the human beings in this world, actually I can get the copy as well. Okay, so we have this thing, Google Advanced Search. If they already put this online, so they put it into server and their server need to connect to internet, and we can search it. So this is the keyword, exact word that you want to search for, and any other word that you want to ignore. If this word is there, then you can say it. So this one is the signature file. So based on a different kind of criteria, okay, we say criteria. So this one is the evaluation of the Boolean query. So equal to this, must have this, but no, don't want this. Okay, a lot of different criteria or Boolean query, you can actually get the result more accurately. Okay, so this one is the indexing text using a database. Okay, so this one is the idea of how good to get the exact copy of the related message based on the keyword. It still need to continue evolve. I say the word evolve. And need to continue to do the changes. So if the searching is good, you will eventually see this kind of a result. So seriously, my son is preparing their exam, and I didn't have a time to make one exam paper for them. So we're trying to look in our Malaysia server, see any of these school is actually publishing their exam paper online. So yeah, eventually I find some. So this one is the result. So it can even browse it year by year, subject by subject, and of course we need this marking scheme as well. So suggest answer. So this is the result. Then you can just simply download, and of course you need to give the download file a name, so easy for yourself to do the comparison or refer next time when you want to mark the paper. Okay, so this one is the full text database system. It mentioned it must support efficient evaluation of this Boolean theory. So this is some keyword. Next, compared to the full text database system, we have another one, indexing of the web. So just now we mentioned the example is only indexing our own material, paper, newspaper, article, or any of the research in our own organization. So let's say example is the library, museum, or even the primary, secondary school, or even your own company. Okay. So after you do the digitalize, you still need some kind of indexing of method. So that is only for one organization, a small part of the world web. When it comes to this part, say indexing of the web, this one is a very big problem. mentioned, you can continue to do research in this indexing structure or method. This is because of this indexing of the web. We know if you research something from the internet. Okay, so let's say you search something from the internet, actually, yeah, it eventually show you. You know what? A little bit different version here. Okay, so you can see if you key in the keyword, actually I'll show you the result. So you can see this one is already million, so this one is billion. 9 billion plus 9.5 is already nearly 9.5 billion result in 0.47 second. Okay, so this one is another example. If our indexing is good enough, then you can get the result. You can see 9 billion, 9 billion of the result regarding this index structure. Okay, so we know if you want to index the web, it's actually a lot. So you can see only a one keyword index structure is about 9 billion records. How about all others? How about all others keywords? How they actually are going to save or store this kind of a result? Okay, so we have this thing called not yet. Okay, so a web search can cover at least 1 billion document, and our example here is 9 billion plus. And a web search engine can serve 100 or 1,000 of query per second. So just now, after we type index structure and press enter, we only use 0.47 seconds and show us all the results. So you can see from here is the searching is a lot, and the result shown to the user is also quite a lot. Okay, so continue on to this part, you can see we have a user here. And this is when you open Google searching or Yahoo or even Bing or any other searching engine, it actually do the searching to the index. And of course, we have some advertisement here as well. So this is the part that we normally do. But for the index, the web, it actually joining this web crawler here. Okay, so we will mention this web crawler later. So just now for our example, the individual digitalizer of this text is of course the web here. We have only one paper, a lot of paper joining together, and it may have the website of joining all these documents all together. Okay, so this one is a picture that you should know. And use an index is to increase the speed and efficiency of the search of the document. So if we have an index already, and when the user actually search for it, you can just directly return the result. So our result here is 9 billion for 9.4 billion record. So you can only within 0.47 seconds, you can get all the results. So this is the result. Okay, most of the search engine actually are using this inverted index. So we'll go to this inverted index later. So this picture you may need to memorize and continue. The major text index method, we have the inverted signature and also this substring tree and array. This one didn't have any explanation. We just go through this too. Okay, so inverted index, you can see from here. The inverted index structure is composed of a vocabulary and occurrence. So vocabulary, the first part here is the vocabulary. And how many documents is actually have this keyword? So only one, this one got two. Okay, so this one is the hash table, a different kind of a hash table. Okay, so the vocabulary is a set of different words in the text. So this term or the vocabulary will be continue or increase. Okay, so of course when the database is built, it only have maybe few, and continue when the user keep asking question or press key in this search keyword, then it will continue to build this term. Okay, so for each of the words, the index will store the document ID. So document ID and then the occurrence in which the word is here. So document ID, where is it linked to, and how many times it actually appears. So a query with the conjunction of several terms is evaluated by the retrieving the inverted list of the query terms one at a time and intersecting them. So this last part here, we already have this keyword, we already know the document. So if we type something, let's say just now we type index structure, then it will link based on the term, then link it, and try to use this intersecting method. See which one is actually a link to the same location, then it will display the result. Okay, so this one is what we call the index, the first view, the first view. We also have a few more examples that I need to mention for the inverted index. Previously, we only make this become the web. So we digitalize all our paper, newspaper, article, and with the research paper and put in the web. When we use this inverted index, we actually are trying to change the method. The users not directly access to the web, but actually access to the index. And because of using this web crawler, we actually are trying to update, continue. There is a machine that continue updating this kind of index. There is any of us. It will continue to browse through all the web documents and keep updating this index. And you can see the updating of this web document it is not much compared to the number of searching. So let's say this paper, once it creates, it may live there for maybe 10 years or 20 years. But every time, every second, there is a user actually linking to searching from the index and a link to this document. So for the inverted index, they also tell us one thing. We try to change the method. This web crawler actually continue updating this index. And if the user is agree or clicking this result, then it will have the ranking changes. So the index will keep changing as well. So let's say we have this example here. When we search this index structure, this result appear as the first one. And if I simply just click that they want. So if you go through, you browse through the search result, if you think that it is not related to your topic, I won't think you will click it, right? So this is the reason why it keeps changing. Then the index result is also changed. So let's say today you look for this index structure, you see this result. Tomorrow the result will be different. Okay, so this one is keep changing. So this is another characteristic of this inverted index. Based on the popularity or based on the user interaction, the index is actually changed. Okay, so this is the last part of indexing. We have a 5-minute break, then I'll come back. We discuss, see what else we can do. Okay, before you go, I'll put a plus one here. Thank you. Okay, we already finished our chapter 6, and I haven't started preparing chapter 7 yet. So from now until 5 o'clock, anything want to do or anything want to discuss? Hong Chang, I didn't see you for a few times. Later, midterm is from 5 o'clock onwards. Yes. Okay, because although you have a midterm, but based on the school policy, I cannot end up my class too early. Anyway, I need to have 6 to 8. You still have some time to have your dinner, then only you start. Okay. I need to arrange the replacement class. Last time I cancelled all the lecture class and tutorial class, practical class. So I need to find another time, but I only can have a replacement on a Saturday. So all other times I think it was already whether you are already full or booking or I already have another schedule. Okay, so this is the time that I try my best to do it. 9 of April, 10 to 12 p.m. Another one is 1 to 3 p.m. So the first one is for the 2 to 4 p.m. class, practical class. The second one, 1 to 3, is for the 4 to 6 practical class. Is it okay for both groups? Okay. Okay, so okay. So the reason I have chosen this time is because for you need to submit your assignment by 1st April. Then I still have a few more days to read all your report. And only on Saturday you can start your presentation. Okay, so this Saturday, this 9 of April is your presentation. Yes, Casey? Oh, okay. What's the time? Okay. Means the whole group? Oh, then I change to 16. Okay. Okay, so I still need to discuss or apply from the program leader because for practical we should go back to campus. But because of this replacement, I find it hardly to book a computer lab. So normally we will just go through online. So if a program leader allows, then this day will be fixed. If not allowed, then I have to go back to campus and discuss or apply with the computer lab assistant, which time will be more appropriate. Because from Monday until Friday is already almost full. Not only you full, but my schedule is also full as well. The day I asked the Junkit send me another timetable, but he didn't do anything. Junkit, inbox you now. Okay, so maybe send me from 4th of April until 16th. See which date will be better. Okay, same thing, you need to send me your timetable from 4th of April until 16th of April. Okay. Okay, so student, I got really nothing to do, but just try. Let's try this. Here, Kinsey is not here. It's Po Yang here. Yeah, Po Yang here. Okay, student, I did mention previously, I say for the practical 4, there is no answer. So student, I need to do it, then only I try to modify. So everyone will have a basic idea. I didn't say this one is the perfect answer. As I mentioned, there is no one thing called perfect answer. Not only for our practical, this one is just suggest. If you find any better solution, let me know. I will just discuss with our students. Okay, so you can see from here, I get the help from Chin and Po Yang and Wei Biao. Try to modify the answer or even just use their answer and just demo it here. So all the students have the basic idea how this practical is actually do, and you have the basic idea. So you can do some changes and based on this idea, try to make one for your assignment. Okay. So previously I did mention the semester is quite short, and we learn a little procedure. And we learn a procedure only 1 to 2 weeks. Until now, it's a week 3 lah. It's minus the week that I cancel. So it means we won't be possible to have a professional answer to the practical question. So my requirement is only ask you to do modification. So if you already have the idea how we're going to do it, you based on our practical 4 sample, try to do the modification. Okay, so this one is my suggestion. I didn't ask you to create a new one. It is not practical. Okay, so for practical 4 question 1, so I just go through. I just go through. If you have any please not really understand, then we try to discuss. So this is Chinzi's answer. Just use it and discuss or elaborate what is the main part. Okay, so the question here say want to print all products for a product line. So all product based on the product line, we list out all the products. So the starting is where the product. Good. Elvin, do you send me any answer for this? Elvin? No. Okay, so we still need to think. Thank you, Chinzi. Okay, we have this practical 4 question 1. Print all the products for a product line. So the parameter that we need to key in is the product line. Then we search everything that is needed from the product. This is the keyword where the product line is equal to the product line that we enter. Okay, so this one is the thing that we key in, and it will based on this product line show everything. So continue on to this part. This one is the procedure that need to do. Open the product cursor. So when it say open product cursor, this query will be verified, validate to the database table. See whether all these things is there or not. Only when you say fetch product cursor into every of this variable, it actually start doing the task. Okay, so pay attention. This one is only validate, and this one is after they do the selection, continue to to populate the data into every variable. Then I'll continue this part until it say doing the looping. So every time the variable will be fetched in. Okay, will be fetched in. Then I try to display to the screen. At the end, have a one line space and start another loop again. Okay, so this one is the how this picture how question 1 is actually doing. So pay attention to this part. Start from loop here. We have a fetch at into and then exit and then an end loop. So previously the answer that I have the answer that I received from I think Poyang or want to Poyang. Yeah, I think Poyang. Some part of this is missing, so it go into infinite loop. So I got no choice but close the whole PL. Okay, so this one okay. Any problems? Should be easy on this one. Only the problem that I see from students only this part I think missing, or the keyword here is not correct. Only these 2 I see. Okay, so until now I only received 1, 2, 4 submissions to GC. I think 2 to 4 submissions from email. So this is some sample. If no problem, I continue to the second one. Okay. Okay, so this one is the result. If everything okay, the result come out should be something like this. So this one is the product line that I choose is a classic car. So if you list out all the products and all others attribute, we just simply choose so it doesn't matter what attribute you actually are using, but you need to make sure the procedure is running successfully. Okay, if no problem, then I will continue to the second one. Okay, I received something from I think Poyang and also return the SQL as well. We always have a problem about this date. So some of the forum they actually suggest us to use Vacha tool rather than Indeed. Reason is when we develop this procedure, you do not know whether the user will key in Monday year or day month year or year Monday. So based on the different country, they actually have a different kind of a date format. So for US, it is month first, then only day, then only year. Okay, for UK, it's a day first, then only month, then only year. Okay, so this is a smaller difference, but when we write our program or write our procedure and accept this input from the user, we actually do not know which kind of format actually matching to our database. Okay, so even forum didn't specify which one is the best method, but trying to use Vacha and then convert to a specific format. So that is what the suggestion. Okay, so of course, Chinzi's answer here is using date as a parameter. the one that I returned to the student suggest to use WhatsApp. Okay, so based on the date between this period, we want to list all the order details from the order that is based on that is between this period. So the sample will refer back to previously I mentioned if a question one, then refer back to the example of practical for sample two one. Okay, so this one is actually referred to the sample two. So we have a two cursor here. So previously we have only one cursor, then it will be easier. It will be easy. So when we go through, it seems like we do not need to stop in a specific location. We can continue based on the structure that listed in page one of our practical four. But for this one, it seems like we need to pay attention if we have something wrong, closing or looping, fetching, exit, then it will go into infinite loop. Okay, so we have a sample here. We have the date. Then we also create two more special variable. One is the customer total amount, and then another one is the all total amount. So accumulate all the customer total amount will be the all total amount. Okay, so this one is something adding to the example. Okay, we also I also found out that if I only use 7 or 8, then eventually it will mention that the variable is not able to hold this amount. Then it will eventually stop running and give a warning. Hopefully it can run because we do not know all the number added together what is the amount is actually accumulated. So we just tap. Okay, so we have a two cursor. One is a search from the order, another one is a search from the order detail. So you can see from here, previously I mentioned when we use a cursor, when we use a cursor, the good point is we search one from a table, search another one from a table, and this one we will put it inside memory. Okay, we'll put it inside memory. So this one is the good point. Then we can continue or do some modification. We can try to do something, let's say plus minus multiplication, and eventually we show all the results. So the starting here is printing all. Yeah, the starting here is printing from the order table. Then I'll continue on to the second part here is printing from the order detail. So based on the order number that we have, then we can continue printing. Okay, I want the order detail of this order only. Okay, so the starting here is the customer number, order number. Then this part is the order detail until the end. This is something that we important point of this important point of the procedure. So normally we try to do something, whether it's inside the first cursor or second cursor looping. A lot of times I mentioned if we can do some of the multiplication or any of the arithmetic process in this part, then we try not to do anything inside our cursor selection. Okay, so when we do the selection, if not really needed, so we just get the value, then do whatever that we can do for the arithmetic part inside here. Okay, so this one will not make a burden to the server. Actually, it's the same, but whether it's using your own computer or the server. But next time when you go to work, it actually when you go to work as DBA, it actually have the consideration. If you can do this in your own computer, then I try not to run it in the server part. So this one is seriously when I work as a system DBA, this is my concern. If too many requests to the server, it may eventually hang. Okay, so Windows system, the memory management is always a bad point. So if anything goes wrong, then eventually the data will become. Okay, so this one is my suggestion. I think all others should be okay. This we already mentioned. Only at this part and the way you close it, the way you end the loop is the main point. And this is the thing that we for this question, we want to have a one total amount, and this total amount will be accumulated every time when this C total amount is get from the database. So it will continue do the accumulate until the end. Only try to print it up. Okay, so this one is something that we can do, and we didn't give any burden to the server. Okay, so this one is the second Q2 suggest answer. Again, I didn't say this one is the perfect one. Okay, so if everything is okay, then you will continue to do the printing based on the customer number, order number. Of course, it's based on the order number. So this is the order number, and inside have two order details. So it mentioned number of order detail in this order is actually 2. Then at the end, after print out all the order detail, after print out all the order detail of order ending, then only I try to print out actually how many order is within this time period. And of course, you also do the this one is wrong. The total order amount between this period is actually this amount. Okay, so you can see that the number is quite large. That's why we need to set the data structure. I think I will can. Okay, so if you see any of this result mention that the data structure can hold the value, then I try to change this to increase the amount. Okay, so any problem for this part? Okay, question 3, say report, showing the report. Okay, so compared to the previous one, it didn't say showing report. So for this part, you need to organize your output. When the question say report, it means that you need to make some table or this right make some setting to the output. Okay, so report to show our old customer. The last order is already greater than 6 months and indicate the last order value. Okay, if can see from our example or the database, all the record is already over six months. It's more than, I think, more than 36 months also. The last record that we have is, I think, 2005 or 2006. That is, I think, 10 years ago, or even yeah, 10 years ago. More than 10 years. Okay, so the table is not updating, but our sample is still there. Okay, so this part we have one view, and we say we haven't touched this part yet. Later, another practical will see it. So a view is actually something that are put into memory. It looks like a table, but actually not. It actually not the database. Okay, so during our practical 5, we already mentioned if we want to do something changes to the table, and if it is a complex one, then we wouldn't be able to do any changes. But for this view, yes, we can try to do some changes to this part. So we want a view easy for us to select the data. So this part we say having a month between the system date and the mix date is already greater than 6 months. Okay, so this is the view. Then I'll continue. We also have this total amount and the last order date. This part we need to organize it. Okay, so we have this part say the quantity order times the price each will be the total amount. So this is the amount that we need to show at the end of this report, saying that the last order value. Okay, then this one is the format of the report. So when you submit your assignment, if your report format is not tidy, then some mark will be deducted. So I think previous subject you already have the idea how you're going to make this report. So I just skip from this part. All others I think should be okay. We can see. Okay, this part I didn't change anything. So the whole practical is refer for margin. So any other problems here? Okay, so you can see if you just simply select and it won't be tidy. So if we try to do some table arrangement, then you can see this is the kind of report that we can accept. Okay, but no problem, then we can continue with this part. Q4 again is a report showing that the profit margin for each product. This one when we say profit margin for each product, now we have two kind of answer from a student. So I just go through see whether it's logical. Okay, so the first one that we have here is based on the price each minus the buy price. So this one is the profit. Okay, so based on the profit compared to our buy price, so it will become the price margin. This one is one kind of a solution. Okay, so just do a checking here. So we have this profit margin. You can see the profit margin is actually using the total profit divided by total buy price. So this is the average profit margin. So the question asks us to show one profit margin for AB product. At the same time, at the end, you also want to show one average profit margin for the wholesale. Okay, so this is the difference from this sample and the second sample. So others I think should be all the same. Whereas the second sample here is actually from I think from Waytel. I just try to do some modifications here that you can use on it. Okay, previously this one is based on the buy price, the profit and the buy price. Okay, profit and the buy price. This answer is only a search for the product table. So it use this the suggestion price minus the buy price and divide by buy price. So this one will be the profit margin. But based on my understanding, the suggestions pricing is not always valid, because every time when I receive this suggestion price, the price that I set is a little bit lower. So compared to others, then people will come to my shop to buy this product. Okay, so this is the difference between the previous sample. So and the last one. Okay, buddy. Okay, so no problem. Then we have the last one. This one is the total, showing the total units sold, and want to list from the highest to the lowest. At the end, we still want to show the total sales value for each product. So we have this one. So product name, we also have this total unit sold. So this is the one that we actually need to mention. And of course, the last one here we have a total sales. Okay, so the order will be based on the total unit sold, descending order. So the highest will be at the top. So we begin do the printing of the header. Then only open this product sales cursor. Catch everything. Okay. I think this part, question 5 is not difficult compared to question 4. We have the ambiguity of this how to calculate profit margin. There's no formula given. So some students may think that it's using the suggestion price. Some may use this price. Okay, so if no response, no say yes or no. So I assume everyone clear about this practical 4. Okay, so Thursday, we will continue our practical 5 exercise. So based on your previous group, you will be assigned to the exercise question 1 to 5. Question 6 to 8, I haven't started looking at it yet. So students, please try to do your part. As I mentioned, if previously you are in charge for question 1 for practical 4, and now you're still in charge for question 1 for the practical 5. Okay, so during Thursday's practical class, then we will have an answer a little bit earlier. We do not need to wait for another week. Okay, so we end here today, and see you again Thursday. Again, take care. If possible, stay at home, don't go out.